Hi, everyone. I'm here to talk about deep brain precision. My name is Taylor. This is Ashley, John, and Danny. So deep brain stimulation is a procedure that's done for patients with motor disorders, such as Parkinson's disease. And it's a procedure that can really improve someone's quality of life. It can be the difference between being able to use a cell phone or not being able to use a cell phone. And this is a procedure that's being done, it's increasing exponentially year on year because of an aging population and because the indications for the surgery are expanding. The leads that are placed in the patient's brains are very complex, and there are hundreds of different potential combinations of parameters that you can get, and there are programming sessions to find the right combination for each patient. So I've been in on some of these programming sessions, and I've seen three problems with them. One is time. So the average patient has to come in 6 times after a procedure in the first 6 months, and each of these sessions is hours long, and you need a highly specialized neurologist and a neurology nurse to sit with this patient and do the tedious task of comparing tremors and handwriting samples for hours to try to get to the right programming settings. Second is optimization. AI people would consider what the neurologists are doing to be kind of like a grid search kind of thing, where they're kind of randomly sampling from all of the hundreds of different parameter combinations and trying to figure out which one seems best for the patient. And then third of all is just subjectivity. What you're doing is you're essentially comparing tremors over hour-long sessions, comparing handwriting samples and trying to see what's best. So our solution is a tablet-based app that syncs with wearables such as the Apple Watch, and it uses objective measures to measure motor function. So for example, the integral between a patient's tracing of a spiral and the spiral itself, or a tremor on Apple Watch. And it's backed up by AI, by a Bayesian reinforcement learning algorithm that allows intelligent sampling of parameter combinations so that the app itself can learn about the relationship between parameter combinations and patient functionality and patient side effects. And that way that we can find the best combination for the patient and not just a good enough combination.
So for physicians, instead of spending hours manually adjusting patient settings, they'll have more time to see more patients within the course of a day. Furthermore, not only are we finding the optimal settings for each patient, but having them wear wearables mean that we have both active and passive data collection so patients can continually calibrate their settings as neurodegeneration progresses and, continuous calibration as neurodegeneration progresses instead of waiting for neurology appointments that only happen a few times a year. Lastly, this will reduce medication requirements, which is critical for Parkinson's disease patients. Market validation, about 160,000 patients undergo DBS implantation a year, all of which require calibration, which costs about $1,700 per patient. These are market statistics: 16,000 users, $1,000 per patient, about $16 million in annual sales. Thank you.
Who would cover the cost of the wearable? Of the wearable?
Yeah, so it's designed to be, right now there is no wearable in use. It's essentially patients are sent home with an iPad that's kind of the remote that they use to program themselves. There's an accelerometer in the iPad that you can just use itself, holding it, and you can use the drawing task. And then if they have a wearable, that just adds more data.
Data in terms of its effectiveness?
I'm sorry?
Data in terms of its effectiveness.
We haven't tested it yet.
I like this idea. As someone who helps do these surgeries, I can say that definitely it is a random grid search is what happens in the clinic, and the idea of shortening that and shortening the turnaround time to actually having therapeutic stim settings is very appealing from a clinical perspective. I guess I feel like I'm not 100% sure that maybe Medicare would be willing to pay for it. But there might be some kind of synergy too in terms of a lot of companies offer these devices and they make a lot of money off the device placement. Maybe some kind of partnership is making that part of the offering. If you use the St. Jude device, for example, they have access to your app for the programming. Could actually be another source of benefit and revenue for you.
That's a good idea. Yeah, something we were thinking about also is just hospitals could offer it as part of their we're providing you this surgery. One of the perks of doing it with us rather than doing it with another hospital in the city is we have this that lets you calibrate at home and it's faster and all that.
I mean, it's awesome to see it removes the subjectivity in tremors. That's key. I mean, that's huge, right?
Yeah, I mean, when I was in the session, it was just nuts because you know, it's an hour-long session, 2-hour-long session, and you're like comparing tremors, and you try another setting an hour later, and you're like trying to figure out how that compared to tremors an hour ago. It's crazy. Thank you.